Hey everybody, we're on the home stretch now. Just a couple examples left. I want to show you where the sum and difference formula for tangent comes from. This will be a pretty straightforward proof. Again, you don't need to know or be able to do this on your own. You don't have to know how to do this. You just have to know, I just want you to know where they came from. And of course, they came from the sum and difference formulas, the difference formulas for sine and cosine, which the difference formula for sine came from the difference formula for cosine. And so you need to be able to use and apply these formulas, but you don't have to be able to derive them like I'm doing here. I just want you to know where they came from. Okay, so if I want to prove the difference formula for tangent, I'm just going to use the identity for tangent, that tangent is sine over cosine. And then I can use the difference formula for sine, which is sine of u cosine v minus cosine u sine v. And the difference formula for cosine, which is cosine u cosine v plus sine u sine v. And then basically what I'm going to do is I'm going to come up with a common denominator for everything. I'm just going to multiply everything by cosine u cosine v, or actually I'm dividing everything by cosine u cosine v. And what that does is it gives me sine u cosine v over cosine u cosine v minus cosine u sine v over cosine u cosine v. So I'm just dividing every single term in here by cosine u cosine v. That makes this term right here equal 1. So this becomes 1 right here. And we can see this is like a tangent, and this is a tangent. This becomes 1. This is a tangent. This becomes 1, and this is a tangent. And so we're left with tan u minus tan v over 1 plus tan u tan v. So this is our difference formula for tangent right here. And there's also a sum formula for tangent, and we can derive that using that same subtracting a negative v thing. Tangent's an odd function, and so that's how this gets switched from a negative sign to a plus sign, and that's how this gets switched from a plus to a negative. Okay? So let's use those sum and difference formulas in this next example. We're actually just going to use the difference formula. Now, something that I want you to be aware of for especially tangent, and this is going to help you on your problem set today, is that these formulas go either way. These equal signs mean that these aren't even different things. So if you see something that looks like a difference inside of a tangent, you can go ahead and rewrite it like this. But also, if you see something that looks like this, you can rewrite it as the difference inside of a tangent, or a sum if you see something that looks like this. So these formulas work both ways, and that's a little hint for you on one of the problems on the problem set for today. So just make sure you know that you can use these formulas in both directions. Okay. So we're going to verify this identity. Okay, we're going to start with the more complicated side, which again, this is more complicated because there's two terms inside of the tangent. So I'm going to start with the left side. And the left side is tangent of pi minus x. So I'm seeing this as the left side of my tangent difference formula. And u is going to be pi and v is going to be x. So this is going to give me tan of pi minus tan of x over 1 plus tan of pi, tan of x. Now tan of pi, sine of pi is 0, so sine over cosine, so that means tangent is 0. So this is 0. This is also 0, which makes this whole thing 0. And so I'm left with negative tan of x over 1, which is the same thing as negative tangent of x. And that is exactly what we were trying to get. And so I have proved the identity. Okay? So that's it for today. Again, if you need to, rewatch any of these lecture videos and then do the problem set that is on Blackboard. And please submit it by the due date. All right? I will talk to you all soon and see you in the next video.